Hello class, welcome to this video on Geometry, Chapter 7, Lesson 6, Trapezoids. This lesson involves trapezoids and kites. However, we are just going to focus on trapezoids and not on the kites here. Alright, so you may consider this as maybe a part 1 of the lesson, but we are not going to focus on kites in class as far as I'm aware, because we're going to just, the focus is going to be on the trapezoids here. All right, so what special properties do trapezoids that are not parallelograms have? So what is a trapezoid? A trapezoid is a quadrilateral with at least one pair of parallel sides. Now, with this new definition here, this means that, according to this definition, you could have two pairs of parallel sides. Before, the definition was one pair of parallel sides, right? This new definition is at least one pair. So, conceivably, if you had two pairs of parallel sides, then you would have a parallelogram that would also be a trapezoid, according to this definition. Right? So you just have to be careful of that. Now, this is an example of one pair of parallel sides and not two, right? So most of the time, a trapezoid, you're going to have one pair of parallel sides that we want to focus on. Now, if it's not a parallelogram, like in this picture, you're going to have different types names for the sides here. The bases are the parallel sides. The legs are the non-parallel sides. Okay, so the parallel sides are called the bases, and the non-parallel sides are called the legs. Okay, so then you have angles known as base angles. Okay, so a base angle is formed by a base and a leg. So this would be a base angle. These would be base angles, for example. So that angle and this angle, right? Those would be base angles. So that's one pair of base angles. And these would be another pair. Okay? So you have two pairs of base angles here. All right, so we have angle A and angle B are one pair. Angle C and angle D are the other pair. Now, if the legs are congruent, then the trapezoid is a special trapezoid called an isosceles trapezoid. Okay, so that's a special type of trapezoid. All right, remember that you only have to have at least one pair of parallel sides. So I could have something that looks like this, right? And that would be a trapezoid, as long as these two are parallel, right? So just keep in mind, you could have something like that, and that would be a trapezoid. All right, so let's look at Theorem 7.21 for some of the properties. Okay, so if a trapezoid is isosceles, again, what is isosceles? Isosceles is when the two legs, the two sides that are not parallel, are congruent. Okay, so if those two are congruent, if it's isosceles, then each pair of base angles is congruent. Okay, so this pair of base angles is congruent, and this pair of base angles is congruent. All right. Also, we would know that these are supplementary, and the reason they're supplementary is because of the consecutive interior angles theorem. I'm going to show you that here. So I'll show you an example. Suppose you have an isosceles trapezoid, and they give you one of the angles is 30 degrees. Okay. Well, if it's isosceles, according to this here, then the base angles have to be congruent, right? So then if that's 30, then this is 30. And then these would have to be congruent as well because it's isosceles, according to this theorem. Well, then how do I get it? Well, remember that it's a trapezoid, so at least one pair of sides is parallel. So we have this pair. This is a parallel set of parallel sides. And so if I were to extend it, see that? So you got your parallel side on top, parallel side on bottom. And then we're going to introduce this side here. But notice that this makes that trapezoid that we're talking about. And this is the 30-degree angle. We only want to focus on this side though. This is why I put this side in dashed, okay? Because we're not focusing on that right now. Focus on this side. We got the sandwich model. We got the two parallel lines and the non-parallel line, the transverse line. All right, so how do I figure this angle out? Well, these angles are consecutive interior angles. Consecutive interior angles. And so that means they're supplementary by the consecutive interior angles theorem. All right, so in that case, it's going to be 150, right? Because it's 180 minus 30. Okay, so that's how you figure out these angles. 150, 150. Okay, hopefully that made sense. But now, let me just zoom in on that so you can see that. So hopefully that made sense there. So now we're going to look at the next theorem. All right, so if a trapezoid has one pair of um, congruent base angles, then it is an isosceles trapezoid. Isosceles trapezoid. So what we were saying is that if you have a trapezoid that, and we're able to show that one pair of the angles, the base angles, is congruent, automatically that becomes an isosceles trapezoid. We don't have to show that both pairs are congruent. We only have to show that one pair are congruent. And why is that the case? Well, this is based off of what I just said here. If we prove that these two angles are 30, both 30 degrees, well, then that means that the lines here have to be parallel because um, in a quadrilateral, the angles have to be equal to 360, right? 360 degrees. A triangle, the angles have to be 180. In a quadrilateral, they have to be 360. And if these two angles are the same, right? Well, and you don't even have to look at the 360 part. You could just say, well, it's a trapezoid, and so it has the parallel sides, the two parallel lines. So even scratch the 360 part. Just looking at the parallel lines, and then you know that both of these are 30. Well, then these are consecutive interior angles using the sandwich model. And so therefore, because these are parallel and these are consecutive interior, they have to add up to 180, and therefore they're both 150, right? And then if all the angles are congruent here, then the base pairs then has to be isosceles. Okay, so it's really easy to prove that because we already kind of did the description for that onto the right here. All right, so 723, a trapezoid is isosceles if and only if its diagonals are congruent. Okay, so they're saying this is isosceles if and only if. If and only if is a two-sided condition. You can two-sided arrow. You can go from left to right or from right to left. Okay, that's what that means. It's a biconditional. So it says if and only if its diagonals are congruent. So if I had diagonals that are the same length, so this diagonal is congruent to that diagonal, then has to be an isosceles trapezoid. Okay. All right, so let's look at our first example. It says the body of the guitar shown is a trapezoidal prism. The front face of the guitar is an isosceles trapezoid. They say AB is equal to 3x minus 2, CD is 3x plus 9, AD is 4x plus 5, and BC is 5x minus 6. Okay, so let's label this. This is just a zoomed in version of that. So we got AB is 3x minus 2, AD is 4x plus 5, BC is 5x minus 6, and then CD is 3x plus 9. Okay, so they told us that it's a trapezoid. Therefore, these have to be parallel, right? You have to have at least one pair of parallel sides. Now, these are not, you can see from the picture, but we can see that we have at least one pair of parallel sides, right? And they said it's an isosceles trapezoid, so that means that these two legs have to be congruent, okay, by definition. All right, so we're given that it's an isosceles trapezoid. We know that those are congruent by definition of an isosceles trapezoid. And so we know that AD is equal to BC because of definition of congruence. If they're congruent, then they have to be equal, right? So definition of congruence. And then, so then we're going to now replace this with those respective parts. When we replace something with another, we call that substitution. Okay, so we're doing a substitution. And then we're just solving that. So notice that here, to get from there to there, we subtract 4x on both sides, okay? So when you subtract the same thing on both sides, you get this result here. And we call that a subtraction property. So substitution property, and then we got subtraction property, all right? Now, to get from step 5 to step 6, I have to add 6 to both sides. So we call that an addition property. All right, and if 11 is equal to x, then x is equal to 11. So when you switch them, where you have a equals b, then b equals a, we call that symmetric property. Okay, there you go. So we now know that x is equal to 11. We've proven that x equals 11 with an algebraic type. It's an algebraic geometric type of proof. All right, so now we're going to go ahead and just kind of copy this part here, there, transfer that over, so that we can answer parts B and C. Okay, so let's look at, so we said that this is 3x minus 6, this is 5x minus 6, 4x plus 5, and 3x plus 9. Okay, same picture as before. Now it's isosceles, so we said that these are congruent, and these are parallel because it's a trapezoid. All right, so they said in part B, find the measure of angle A if the measure of angle C is 72 degrees. Now we know that if it's an isosceles trapezoid, these have to be congruent. Okay, um, so that's the case. So then if this is, and then we know that these have to be congruent as well, right? These are congruent, these are congruent. Those are the base angles. So if this is 72 degrees, this is 72 degrees. Okay, and we also know that by the consecutive interior angles theorem, that these two are supplementary. Okay, so all right, so we have that. So because ABCD is an isosceles trapezoid, we see that angle C and angle D are congruent base angles. And we see that angle C is equal to, the measure of angle C is equal to the measure of angle D, which is 72 degrees. Now, because it's a trapezoid, we see that AB is parallel to CD. and therefore we can use the alternative or consecutive interior angles theorem, right? So let's draw that out here. We have this side here. Let's grab that side there. Those are parallel, and we have this line, which is DA, and we're looking at this angle and this angle, okay? And you can see that those are consecutive interior angles, right? Therefore, they have to add up to 180. All right, so then we're going to go ahead and do that by the consecutive interior angles theorem. Oops, this should say angle D. Sorry about that. Now we're going to make a substitution. Replace that with 72 degrees. Then we're going to subtract 180 on both sides. So 180 minus, or 72 on both sides. So 180 minus 72, that gives us 108 degrees. All right, so that takes care of part B. Now part C, find the perimeter on the front face of the guitar in centimeters. All right, so the perimeter of any geometric shape is just the sum of the sides. So we're going to add up all the sides, 1, 2, 3, 4. All right, so if we add up the sides, we get, we're just replacing these to AB plus CD plus BC plus CD plus AD. Add up all four sides. We're going to substitute that because we know what the sides are equal to in terms of X. Now we're going to combine our like terms here. So 3x plus 5x plus 3x plus 4x. That's going to give you 15x, okay? Now we're going to combine the constants. So we got -2, we got -6, we got +9, and we got +5. All right, so if we did that, add those together, we got +6. All right, so now we know that x is equal to 11 because we proved it in part A. So we're going to take x equals 11, we're going to plug it in. And so do that substitution. All right, and then we get 165 plus 6 plus 15 times 11 is 165. Add that 6 to that, you get 171 centimeters. All right, so we have our perimeter as shown. All right, so that's example 1. So let's look at example 2. Example 2 is involving coordinate geometry. So what we're going to do is we're going to first prove that QRST, with the coordinates given, is a trapezoid, and then after which we're going to determine whether it's an isosceles trapezoid. So first trapezoid, then determine if it's specifically isosceles. How do we determine if it's a trapezoid again? Well, remember that you have to have at least one pair of parallel sides. Okay, so if you have the one pair of parallel sides and the other pair is not parallel, then it's a trapezoid. It's a trapezoid that's not a parallelogram. But you have two pairs of parallel sides, and that's parallelogram. It's a trapezoid that's also a parallelogram. But we don't. Most of the time, when they're trying to show it's a trapezoid, most of the time they're really saying it's a trapezoid that's not a parallelogram. Okay. So let's graph it, and we get a better picture, but get an idea of what's going on. So we have -8, 4. R is 0, 8. T is -6, -10. And and I forgot to show you point S. So let me write down point S. Sorry about that. Forgot to give you point S for this four sides. Okay, and the coordinates of S are 6, 8. Okay, so sorry about that. 6 and then 8. Okay, so we're going to actually let me put S over here. Put it there just to so that it's all lined up. Okay, so we're gonna now that we have the coordinates, we can make the graph. Oh, oops. This is going down at -4. Sorry, it's -8, -4. Here you go. That's better. Now it kind of looks like a trapezoid here. But we want to show that it's a trapezoid. It looks like one, but we want to actually prove to that that's the case. Okay. So, looks like a trapezoid. Looks like these are not parallel, and then these are parallel. We need to prove them, okay? We need to show that that's the case. So we're going to look at the slopes of the opposite sides. So slope of QR, slope of ST, and we have the slope formula. These are given in the formula sheet, so no need to memorize them. So I just provided them for you, but they're in the formula sheet for the EOC. So QR and ST. Let's do the slope of QR first. So we subtract the y coordinates, right? According to that formula, y2 minus y1. All right, so 8 minus -4. And then subtract the x coordinates here, 0 minus -8. So 8 minus -4, that turns into a plus. So 8 plus 4 is 12. Turns into a plus, so 12 over 8. Okay, now that reduces, we can reduce that. So let's divide that by 4. And we get 3 over 2. Okay, so there's our slope. And let's do slope of ST. All right, so for ST, okay, this is why I wanted to put them like this. So subtract the y coordinates, so 8 minus -10. And then subtract the x coordinates, so 6 minus -6. All right, and then we got 8 plus double negatives a plus, so that becomes 18. Double negatives a plus, that becomes 12. And let's reduce that. So divide by 6. And lo and behold, we get 3 over 2. And so that indicates that these are parallel, right? So this indicates that they're parallel. So we say QR is parallel to ST. All right, so we've shown that these are parallel, which means by default it has to be a trapezoid. We're gonna show that it's a trapezoid that's not a parallelogram. Okay, so let's show that it's a trapezoid that's not also a parallelogram. All right, so let's show the other two sides. So RS is the slope for that is pretty easy to tell. I mean, you can see it's flat, right? So it's going to be 0. But let's calculate it. So slope of RS. All right, so you're gonna subtract the y coordinates, right? Oops, wrong one. These two, RS, so 8 minus 8, and subtract the x coordinates, 6 minus 0. And so you get 0 over 6, which is 0. That's what we're saying, it's flat. Now, if that's flat and this is not, then that means that they cannot be parallel. But let's just do it anyways. QT to show our work. All right, so we got Q and T, so we're going to subtract the y coordinates. So -10 minus -4 over, and then subtract the x coordinates, 6 minus -8. All right, so -10 plus 4 is -6. 6 plus 8 is 14. Now, let's reduce it. Divide by 2, and it becomes -3/7. Okay, so we can clearly see that RS is not parallel to QT. All right, so far, our conclusion is that it's not a so far as we say it's a trapezoid that's not a parallelogram. So it's a um, trapezoid, but not a parallelogram, right? Okay, so now what we're going to do is we're going to check the legs to see if, by the distance formula, to see if it's going to be isosceles or not. So it looks like it could be isosceles, like these are the same length, but let's find out what they are, okay? So this one is completely horizontal, so if you want, you could just count it. So RS is going to be 3. I'm going to use the distance formula, but we know that the result is going to be 3, guys. All right, but just to practice, we're going to use the distance formula. All right, so to get RS, we would take the square root and we would subtract the y coordinates. Okay, so at R and S, the y coordinates are 8 and 8, so 8 minus 8 squared. Oh, and you don't have to do the y's first. You could do the x's first or the y's first. Doesn't matter. But let me just put that here for the y's. And the x coordinates are 0 and 6. Okay, so 0, 6 take away 0. And again, the order that you do x and the order that you do y within the parentheses does not matter, guys. Because you square it, and you square any number, whether it's positive or negative, you're going to get the same number. Right? So we get the square root of 6 squared plus 0 squared. Yeah, so, and I said earlier that this is 3. That's incorrect. This is actually 3 spaces, which is 6 units, because remember that this is going by 2s, right? That's 2, 4, 6, 8. So this is actually 6. So our answer is going to be 6 here. But we get square root of 36, which is 6. Okay, well, that's not a surprise. All right, so let's do QT. So that's the square root of, now we're going to subtract the y, well, let's do the x coordinates first. So negative 6 minus negative 8. All right, so there's that double negative, which we know turns positive, right? And then, so we just circle that. Usually I circle it. And then the next part, subtract the y's. So we got negative 4 and negative 10. Okay, so negative 10 minus negative 4 squared. Again, that turns into a positive. So we have negative 6 plus 8, that's going to be 2, so we got 2 squared. And negative 10 plus 4, that's negative 6, so negative 6 squared. All right, so we get 2 squared is 4, and then 6 squared is 36, so we get the square root of 40. All right, now the square root of 40 does not equal to 6. If you were to do square root of 40, you get 6.32, right? So approximately 6.3. You can see that they're not equal, right? So you can see that this is not congruent, or is not congruent to this. Therefore, it's not isosceles, okay? So we're going to say it's not an isosceles trapezoid. Okay? But it is a trapezoid. Okay? So the conclusion is that it is a trapezoid. That's um, not isosceles, not a parallelogram. I'm just going to use a symbol for the parallelogram here. Okay? All right, so that's our conclusion. We could write the conclusion on top. That's okay. Just leave it there. All right, so that's our conclusion for that. So pause the video, see if you can try this problem out, and then we'll look at it in just a second. All right, so let's go ahead and take a look at it. It says quadrilateral DEFG has the following vertices. Show that DEFG is a trapezoid and determine whether it is an isosceles trapezoid. Okay, so let's look at that. All right, so let's graph them first, right? So remember, this is going by 2, so just be careful when you do this graph. So when you do your graph, so negative 3, 2, we have D. Yep, E is negative 1 and 6. F is 3, 7, and G is negative 2, negative 3. Okay, so that's how it looks like. So now let's see if DE is parallel to GF. Okay, so look, we need to find the slope of DE. Okay, so again, we're going to subtract the y coordinates. Let's subtract the x coordinates. We got 4 over, this turns into a positive, so negative 1 plus 3 is 2. All right, so we get positive 2 for the slope. Okay, so now let's do the slope of GF. Okay, so GF, so that's going to be negative 2 and 7 for the y coordinates. So 7, oops, sorry. Yeah, so it doesn't matter the order, but you want to be consistent. So I'm going to do negative 3 minus 7, and then negative 2 minus 3 for the x coordinates. All right, so we get negative 10 over negative 5, which is positive 2. So we can see here that DE is parallel to GF, okay? All right, so let's look at EF. So the slope of EF, okay, so we got the y coordinates over the difference in the x coordinates, so 3 minus negative 1, so we got 1 over 4, all right? And then let's do the slope of DG, 6 minus 2. Oh, wait, it's DG, sorry. So negative 3 minus 2, and x and negative 2 minus negative 3. So we get negative 5 over positive 1. Okay, so we can clearly see that these are not parallel. Okay, so EF is not parallel to DG. Okay, so therefore we're going to say it's not parallel to DG. Therefore, we can conclude it's a trapezoid. Okay, so so right now it's a trapezoid. Trapezoid, but not a parallelogram. That's a symbol for parallelogram. All right, so that's what we got so far. Now we're going to see if it's an isosceles trapezoid or not. All right, so we're going to say it is a trapezoid. It is not a parallelogram. All right, so let's find the length of DE. So to get DE, we need to use the distance formula. So distance formula, remember, you subtract the x coordinates, subtract the y coordinates, and then square it. Okay, so you get negative 3 for DE. So negative 3 minus negative 1 squared plus subtract the 2 y coordinates, 2 minus 6 squared. Again, the order doesn't matter. Right, so so this double negative turns into a positive. Negative 3 plus 1 is negative 2. So we got negative 2 squared plus negative 4 squared. Okay, so we get 2 squared is 4, and then 4 squared is 16. So this is going to be 4 plus 16, which is 20. All right, zoom in a little bit. Okay, and let's do, okay, so we got this is square root of 20. Okay, and so that's that. And then let's do GF. Now we know that for this to be isosceles, that DE and GF are not congruent, but DG and EF are. Okay, so we know that that's the case for this to work. Okay, so they want us to find all of them anyway, so we might as well find all of them. Okay, so I'll take the square root. Okay, so GF, so we got negative 3, or let's do the x-coordinates first. GF, so negative 2 minus 3. And negative 3 minus 7. Okay, so I get negative 5 squared and negative 10 squared. So that gives me 25 plus 100. That's the square root of 125. Okay, square root of 125 should be 15. Let's double check that. Or oh, maybe not. Okay, I was thinking maybe a 225. Yeah, 225. Okay, so it's not. 11 point something. All right, so we get square root of 125. We could simplify these radicals, but we're not going to do that. Okay, there's no point in doing that here. Okay, so we're not going to simplify the radicals. All right, so we got EF. All right, so going to subtract the y coordinates, so 7 minus 6. Again, it doesn't matter. Subtract the y coordinates and then subtract the x coordinates. Okay, I'm doing this to show you that it doesn't really matter the order. Okay, and then 3 minus negative 1. Okay. All right, so you get 1 squared, and then this becomes plus, so 3 plus 1 is 4. You get 4 squared. So you get 4 squared plus 1 squared, that's going to be 1 plus 16, which is square root of 17. All right, so last one here. Okay, so let's write this out first. This is square root of 17. All right, and we just got dg. Okay, so dg. Again, subtract the x coordinates. We have negative 2, negative 3. Negative 2 minus negative 3 squared, and that becomes positive. And then we got the y coordinates, negative 3 minus 2. Okay, negative 2 plus 3, that's 1. Negative 3 minus 2, that's negative 5 squared. So, okay, so we get square root of 1 plus 25, which is the square root of 26. All right, so we see that by doing the distances, none of them are actually the same length. It looked like this could have been the same length as that, but no, this is actually a little shorter than that. And so we can see that it's a trapezoid, according to this, but it's not an isosceles trapezoid. Okay, so because so we're going to say, remember the ones that made it an isosceles is DG and EF. That did not make it an isosceles. So if DG and EF were congruent, it would have been isosceles. But because DG was not equal to EF, it's not an isosceles trapezoid. Okay, so we're going to say it's not an isosceles trapezoid, and we said DG was square root of 26. All right, so now let's look at segments of trapezoids. So we've proven that whether something is a trapezoid, whether it's isosceles, whatever. Now let's look at some other properties. A mid-segment. Okay, so the mid-segment of a trapezoid is the segment that connects the midpoints of the legs. Okay, so it connects the midpoint of the legs of the trapezoid. Okay, so here we have a trapezoid. We're going to apply the trapezoid mid-segment theorem, show you where the mid-segment is and all that. Okay, so the mid-segment of a trapezoid is parallel to each base, and its length is half the sum of the lengths of the bases. Okay, so what's the mid-segment? In this case, PQ is the mid-segment. Okay, so this right here, that line is the mid-segment. And notice that it's parallel to the bases, right? This is the base. This is the base, right here, and this is the base right here, right? So this parallel. And in order to find the length of PQ, let's call it C, right? Let's call the length of PQ C, and let's call the length of JK A and the length of ML B. Well, in order to get C, I would take the arithmetic average, so just a average of A and B. So just add these together, divide by 2. All right, so the formula, if you will, is if I want to get C is equal to A plus B over 2. All right, that's what I use. I mean, that's just the formula that I use. This is not a formal formula. This is just a little way to remember is that if I want to get the middle, just, A plus B divided by 2. Just add the bases and divide by 2. Okay, so now that we've described that, let's apply it. So example 3, it says in the figure, UR is the mid-segment. Oh, by the way, one more other thing is that the mid-segment connects the midpoints of the legs. So this is these are legs, right? So this is the leg, KL is a leg, and JM is a leg, right? And so this right here is a midpoint, and by definition, by the midpoint theorem, these have to be congruent, okay? And then this has to be congruent. Let me actually get rid of this arrow. I'll just put it over here, just for the sake of space. So now we're going to say this is congruent to that, okay? That's very important, that in order to determine that this is parallel, well, then these have to be midpoints, okay? So they have to be cut in half, right? So that's a very important concept we'll look at later. All right, so now we described that. It says this is a mid-segment, which means if it's a mid-segment, that's why you see these two, right? That's congruent and that's congruent, okay? Because you have their midpoints at U and R. And that also means that these are parallel, right? So these are parallel. And all right, so if in order to get C, right, we would add these up, divide by 2, right? So C is 11 plus 18 divided by 2. Okay, that's how we get that. But let's just use a description here. So it says, by the trapezoid midsegment theorem, UR is equal to 1/2 the sum of PQ and TS. That's what we wrote here. So in order to get UR, right, which is what I called C, but we can call it UR here, it's half of the sum of PQ and TS. And TS is 18. Okay, so basically 11 plus 18 and then half of that. Okay, so 11 plus 18 is 29 and then half of 29 right there. Okay, so let's do that. That's 29 over 2. And so we know that that's going to be 14 and a half. Okay, so 14.5. That's it, guys. So we know UR is equal to 14.5. Pretty straightforward. All right, pause the video and see if you can attempt the check here. All right, hopefully you paused it and tried it. So it says in the figure, FC is the mid-segment of trapezoid A, B, D, E, and find FC. All right, so we know they don't have to tell us it's a mid-segment. We know it's a mid-segment because by definition, it connects the midpoints of the legs of the trapezoid. Okay, and so therefore it has to be parallel to the bases. All right, so if I want to get C, right? I add A and B together, right? The two bases. Okay, so we got 23 plus 16 divided by 2 is 39 divided by 2. So 2 goes into 39, 19 times, and a half. Okay, so there you go. So then C is FC, right? So then we can just say, here you go, it's 19.5. And that's the trapezoid mid-segment theorem. Remember, know what the name is of the theorems, okay? Trapezoid mid-segment theorem. If we wanted to do it formally, of course, we would say FC is equal to AB plus ED, and then half of that, okay? You could say 1/2 AB plus ED, right? Same thing. It's just a formal way to say it. And then that's the trapezoid mid-segment theorem, right? And so on and so forth. Okay, so let's look at example 4. Find the missing values. So another mid-segment theorem, but we're trying to figure out what x is now. Now we're not trying to find the mid-segment anymore, the length of the mid-segment. We're trying to find the length of one of the bases. How would we do that? Well, we know that this is like our A, our quote-unquote A. This is our quote-unquote B. This is our quote-unquote C. So we get C is A plus B over 2, right? Based on what I said. So then we can say, okay, well, C is 24, and A is X, and B is 16.7 over 2. And then we can solve this for X, right? That's what we're doing. All right, so in a formal setting, Rn is C, and it's half of the length of the bases. So Rn is 24, right? So we're going to do a substitution where we replace that, right? Ln is X, as I said earlier, and then this is 16.7. It's exactly what I wrote here. It just looks a little different, but it's the same thing. So in order to solve here, you have to multiply both sides by 2 in order to get rid of that. Well, that's what we're doing here, right? So we're timesing both sides by 2 in order to get rid of that, okay? And so that's a multiplication property. Multiply each side by 2, right? So now next, you're going to get x plus 16.7 equals, well, 2 times 24 is 48, right? We have 48 here. And so we're going to subtract 16.7. We're going to use subtraction property. Again, that cancels. And so we get 48 minus that, which is 23.3 right there. Oops, sorry about that. 31.3. Sorry about that. So 31.3. And they don't tell us units, so it's just 31.3 units, okay? All right, and that's it. Okay, so we got X. We just boxed that right here, 31.3. All right, go ahead and pause the video and attempt the check. All right, so let's go ahead and take a look at it. So it says LH is the mid-segment of trapezoid FGJK. What is the value of X? All right, so again, this is C, A, and B. These are parallel. Again, I want to emphasize that they're parallel just because we're going to need that later. And then in the future. So here, C is A plus B over 2. Formal way of saying is LH equals FG plus KJ over 2, right? So that would be the formal way of saying it. Well, we'll write it out. Is FG plus KJ over 2, right? That's the formal way. All right, so C, we got 15 equals, and A is X plus B over 2. All right, so multiply both sides by 2. These cancel. We get 30 equals X plus 18.2. Subtract 18.2 on both sides. We get X equals, we get here 11.8. All right, so X is 11.8. All right, so let's look at next example. Last example with the check. So mid-segments and coordinate geometry. So in trapezoid ABCD, we have AD is parallel to BC. Find the endpoints of the segment. Okay, so they say AD is parallel to BD. Well, okay, so if they're parallel, this is your trapezoid. In order to find the mid-segment, we know by definition it has to connect. It has to be parallel to the bases. So it has to be like something like this, where it's parallel. And it has to connect the midpoints, right? That's the definition, right? The definition of mid-segment is it connects the midpoints of the legs, okay? Well, here, the legs are AB and BC. So we need to find the midpoint, okay? So let's write down the midpoint formula. So the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. So that's the midpoint formula. So we're going to apply that here. Add the x's, divide by 2, add the y's, divide by 2. All right, so let's do the midpoint of AB first, okay? All right, so again, we have our add our x coordinates, so 0 plus 18 divided by 2. Add our 2 y coordinates, 8 plus 8 divided by 2. And that gives us 18 divided by 2 and 16 divided by 2. So that gives us 9, comma 8. All right, so 9, 8. We can see that that's the middle. All right. All right, so now let's do the midpoint of the next one, which is DC, or yeah, DC. All right, so add the 2 x coordinates, 1 plus 20 divided by 2. Add the 2 y coordinates, 4 plus 0 divided by 2. We get 21 over 2, and we get 4 over 2. So there you go. So 21 over 2, comma 2. All right, now 21 over 2, that's 10 and a half, right? So I'll just put that here just so that we can graph it. So 10.5, 10 and a half, and then x coordinate or y coordinate of 2. All right, so there you go. So that's 21 over 2, comma 2. Now, if I connect these, oops, let me do that a little bit better. If I connect these 2 points, well then all of these are going to be parallel. Okay, so then that's my trapezoid mid-segment here. All right, so that's it for that. So they wanted us to find the endpoints. So we got this and we got this for endpoints. All right, go ahead and pause video and attempt the check. All right, so all we gotta do is find the endpoints of the mid-segment. It's a trapezoid, so we can say these are parallel. We can also prove that they're parallel. Really easy to tell using slope, rise over run. But it already tells us that they're parallel, so there's no need to do that. All right, so let's find the mid-segment or midpoints of Q and QR. So let's do QR. So add the x coordinates together, -3 plus 1 divided by 2. Add the y coordinates together, 4 plus -1 divided by 2. So we get -2 over 2. We get 3 over 2, which is -1 3/2. So it looks like we got F as one of our midpoints. Let's graph that here, -3 and then 1.5. All right, and then let's do PT. So add the x coordinates together, -1 plus 5 divided by 2. Then do the y coordinates, -5 plus -4 divided by 2. So we get 4 divided by 2, and then we got -9 divided by 2. All right, so we got 2, comma, -9 over 2. All right, -9 over 2 is -4.5. So we get 2, 2 here, 1, 2, and then -4.5. Looks like this one right here. Oh, I said -2. I meant to say +2. All right. And there you go. That's our answer, but let's go ahead and just do the graph. There you go. And so these are all parallel. All right, that's going to do it for the video, guys. Hope you found this useful and informative. And as usual, I'll see you in the next one.